Hello guys, welcome to another wonderful episode of CUDA Education. I'm your host Nicholas Main. Today what I wanted to cover is CUDA device management variables or even functions. But basically it's just a set of variables that affect how the device behaves and what sort of memory sizes certain variables or certain things on the device has. Of course, when I talk about the device, I'm talking about the GPU, of course, right? So this is CUDA Education. There is a CUDA device management. This is the algorithm, and you have cudaLimitPrintFifoSize, cudaLimitStackSize, and cudaLimitMallocHeapSize. A quick overview of device management variables in CUDA. So the first and most important one that I wanted to cover was the cudaLimitPrintFifoSize. So I did a previous video where I talked about debugging in CUDA, and one of the effective ways of debugging in CUDA is to simply print out variable state or print out status of different variables, or status of different things on the device, on the GPU. So whenever you call a global function or a device function, you are able to use printf to print to the console, right, and see what the status of the variable is. So because of that, you want to you might want to print out a whole bunch of stuff, but there is a caveat to printing. If you're printing out a lot of things and it is not if you're printing out a lot of things and it is not it's the amount of things that are generated to be printed is faster than what can be realistically printed on the screen, the printf or the print buffer, there's a size to that buffer, so it sort of stores everything and it streams it to the screen as best it can, or as fast as it can. But then the problem is that there's a specific size to this print buffer, and if more content is generated than what's in the size of the buffer, you start to get into a situation where you're overriding the buffer. So because you're overriding the buffer, the information that is being printed out might not necessarily be printed in its true order, or you might be missing information entirely because, of course, by the time it's about to be printed, the information is overwritten. So as far as I understand, this cudaLimitPrintFifoSize variable is very important. You could make it larger or you could make it smaller depending on your needs, but it's very important, especially when you're debugging. Obviously you want to have some control statements, maybe some if statements or what have you, to prevent you from printing out way more than you need. So if it's a particular thread, or only after a certain amount of processing, then it starts to print the it starts to print out what you need. So that is the importance of cudaLimitPrintFifo, and I will go through an example. Well, basically I'll just run the algorithm and print out everything, but let me go through the other variables and see what we could eventually get there. So the cudaLimitStackSize basically controls the stack size of each GPU thread. So it gives you a little bit more granularity in terms of how much each GPU thread is allocated. Of course, this is dependent on memory memory size available, streaming multiprocessors available, the compute architecture of the chip, of your GPU, all that stuff. And you could look online for a calculation of how to see what the maximum CUDA limit stack size you could use. And then cudaLimitMallocHeapSize is basically it controls a heap size for the entire kernel launch. You have to set this before launching any kernel, and it sort of controls how much memory the kernel has access to. Now, I said all these things before launching the kernel, and I think you know, all of these variables you could only set before you actually launch the kernel. So I pretty much just have an algorithm down here. Of course, disclaimer: this code is for teaching purposes only. CUDA Education or Nicholas Main does not guarantee the accuracy of this code in any way. This code should not be used in a production or commercial environment. Any liabilities or loss resulting from the use of this code in whole or in part will not be the responsibility of CUDA Education or Nicholas Main. Use at your own risk. Okay, so right, so basically what I did, this is just a dummy GPU launch, but it doesn't do anything. So what I do is you start off with you set a variable of type size t, and I just call it size, and then I set the cudaLimitPrintfFifoSize to 1, and then I get the value and I push it into size, and then I just print it out here. And I basically do the same thing for all of them. So I set the cudaLimitStackSize to 1 here, and then I get the size of it and I print it out. I overwrite this variable. I don't know if it's best practices or I should have destroyed the variable or cleaned it before, but anyway. And then I do the same thing for cudaMallocHeapSize. I set it to 1, and then I get the value and I push it here. Now, I'm very new to these variables, and as you will see, the values that are printed are actually not 1, so they're completely different values, and you know, I have to invest some more time and energy into figuring out exactly what's going on. But this is what you get when you set the variables and then you print it out. I will, you know, investigate some more and maybe do some examples where if I could see where maybe the print buffer is very small, and when it prints out information, you could see that it's not consistent and it's overwritten and all that stuff. But that's for a later post. So I will post this code on CUDA. I will put a link in the description below for the actual URL for the post on cudaeducation.com. And you could take it from there and do your own experimenting. So visit cudaeducation.com, catch me on Twitter at cudaeducation, email cudaeducation@gmail.com. I'm also on Slack here. You could donate to CUDA Education at cudaeducation.com, and yeah, I also have teaching and consulting sessions available. So for any of you guys, whether you're in industry and you need to just get up to speed really quick, get your organization up to speed really quick on what's going on and how to take advantage of your GPU processor using CUDA, definitely reach out to me. Or if you're teaching a bunch of students and you want them to learn the latest technologies so that they could be gainfully employed when they come out, definitely reach out to CUDA Education. So yes guys, thank you for watching. Check out the website. I will post the code on the website, and have a great day.